All right, this is section 1.2 for MAC 2233. So the first thing that we're going to do is we have two functions that are defined. F of x is defined as 7 minus 5x, and then g of x is defined as 2x minus 3. So whenever you have f of 2 or f of 3 or whatever value you have, what you're going to do is you're going to replace the variable in the original function with the value that you're given. So then this becomes 7 minus 10, which is going to be negative 3. So in other words, f of 2 is equal to negative 3 given this particular function that we have. So the next one is f of negative 1. So that means I'm going to replace the variable with a negative 1. So we know that a negative and a negative becomes a positive. So f of negative 1 is equal to 12. Now g of negative 1/2 is the same thing, right? We're going to go ahead and replace the variable with the value that they give us. And so this is going to be negative 1 minus 3, which is negative 4. So g of negative 1/2 is equal to negative 4. So the other one is where we sort of replace it with another function, which we can do that. So then this just becomes 2k squared minus 3. All right, and that's the first few ones. Hold on a second, I might think that. Okay, 19. So for number 19, it's actually a word problem. And so in this particular case, we have write a linear cost function for each situation, identify all the variables that are used. So number 19, we have that $10 is the fixed cost. And then the next thing that we have is that $2.25 is the cost per hour. And so X is going to be the number of hours. And then we can say that R of X is going to be the cost of renting it for X hours. Now we could have used any type, we could have used C of X and all that good stuff. So the nice thing here is that the cost function, I'm actually going to use C for cost function because that's what they were asking us. And so just know that the cost function is going to be equal to the fixed cost plus what we call the variable cost. And so in this case, C of X is going to be equal to 2.25x plus 10. So the variable cost is the $2.25 per hour because we don't know how many hours we're going to rent it for. Now for the next few examples, I'll try to do the same thing here. So the next one we're going to do is number 20. And so for number 20 here we have that an internet site for downloading music charges a $10 registration fee. So it looks like the $10 is also the fixed cost. And then of course 99 cents per song, right, that you download. And so for number 20, we're going to have, again, the cost function. And just sort of looking at everything, we can see that this is the fixed cost, this is the variable cost. So then C of X is going to equal to 0.99x plus $10, of course, where X is equal to the number of songs that you download. So that's number 20. Next one we could do is number 23. So number 23 is a little bit different than the other ones. So number 23 here says, assume that each situation can be expressed as a linear cost function. So here it says that the fixed cost is $100. And then 50 items are going to cost $1,600 to produce. So what we have here, in essence, we have an X and we have a Y. And the reason that the 50 items is an X is because the cost to produce depends on how many items we produce. So if I was to write this in an ordered pair, it would look something like this. And so what we have to do here then is we have to sort of figure out, okay, what is, in this case, we're missing one piece of information. And that piece of information that we're missing is the slope, right? So we're missing M. If I were to put this in a function itself, I would have everything but m. Now, the next thing is that we know, if I look at it this way, is that 1600 is equal to 50m plus 100, right? Because we know that that's our fixed cost. So if I subtract the 100 from both sides, now the next thing that I can do is I can go ahead and divide both sides by 50, and I get that my slope is actually equal to 30. So then my cost function will be 30x plus 100. And that's the answer for number 23. The next one is 25. And so number 25 is slightly different. It's telling us that the marginal cost is equal to $75. Then it says that 50 items are going to cost $4,300 to produce. And so what they're asking us is just to express it as a linear function, right? So number 25, this is the information that we have. So if we think about it, this is actually our slope right here. And so since that's our slope, we have our ordered pair again, independent variables items, right? This is my x, this is my y. And so I'm going to have 4,300 is equal to 75 times 50 plus b, because we're solving for b at this point in time. So now you can see sometimes why I actually like to solve for b as opposed to anything else. And so if we do the 75 times 50, we're going to get 3750 plus b is equal to 4,300. So I subtract that from both sides, and I get that b is equal to 550. So then the answer for number 25 is going to be 75x plus 550. Sorry, let me write that a little better. Plus 550. And that's number 25. All right, I'm going to look at number 27. So number 27 is a little bit more involved. What else do I have? 27, 33, 34. All right, so let's look at 27. So number 27, it says, suppose that, let me write that thing here. It says that the price for a certain model of youth wristwatch are related by P, which is equal to D of Q, and this is the demand function, 16 minus 1.25Q, right? And then it says P is in dollars. And then it also say that Q is the quantity demanded. And that's in hundreds. Okay, so that's really important. And so we're going to go ahead and find the price in dollars and the quantity demanded in hundreds for the price level at each demand, right? So what we're looking for is what's happening when the demand is those particular values. So for the first one, I believe is D of 0. So what's the price if Q is equal to 0? And I get 16. So when 0 watches are demanded, the price is $16. Demanded, right? Excuse my handwriting is atrocious. So that is actually A. B is D of 4. So notice how it was 400, but now it turns into 4. So you have to be careful there. And it will make sense, because if you do 400, you'll get a negative value. So D of 4 is going to be equal to 11. So 400 watches a demand for 400 watches result in a price of $11. Now, C is D of 8, because it's 800 watches, so it's 1.5 times 8. And so when we do that, we get a price of $6. So 800 at $6 a pop, right? Now, the next one is Part D, and in Part D is asking us for find the quantity demanded for the watch at each price. So this one's a little different. So D is what they're telling us is that we're trying to find out what it is. What would be the quantity when D of Q is equal to 8? So here we're going to do 8 is equal to 16 minus 1.25 Q. And so here, what I can do now is kind of tweak this one a little bit. So I'm going to have the following. I'm going to sort of rearrange this a little bit. Actually, I'm going to subtract the 16, which gives me negative 8, is equal to that. And then if I divide both sides by negative 1.25, I get that Q is 6.4. And so that means that at a price of $8, demand will be 640 watches. And that's Part D. Now, Part E is the same way. So it says D of Q is equal to 10. Right? And so we're going to have 10 is equal to 16 minus 1.25 Q. And then when we solve all that, we get that Q is equal to 4.8, right? If I solve for that. So at $10, demand is 480 watches. Now the next one that it's asking us for number 27 is F. And you can see here that these have multiple parts to it. Now, and on an exam, I won't give you so many of these. So 12 is equal to 16 minus 1.25 Q. And so when we solve that, we get 3.2 is equal to Q. So at $12, we get demand of, not at, 320 watches. Right, so that's that first part. Now I'm going to skip G. I'm going to jump over to H. And then in H is telling us the following, right? So in H is saying that the supply function is equal to 0.75 Q. So 0.75 Q. Supply function is 0.75 Q. So for H is asking us to find when S of Q is equal to 0, right? So 0 is equal to 0.25 Q. So that means that Q is equal to 0. So that means that when 0 watches are produced, the supply would be 0, right? Because nobody wants to supply anything for free. Now for I, it says S of Q is equal to 10. And so what happens here is that 10 is equal to 0.75 Q. And then when we solve that, we get approximately, that Q is approximately 13.3. And so that means that at a price of $10, the number of watches demanded would be 1,333 watches. All right, let's go to J. So J here is asking us to find Q when S of Q is equal to 20. Again, we set it up the same way. And then we divide both sides, and it's about 26.6. So at a price of $20, you get a demand of about 2,667 watches. Now for K, what they're asking us is to graph those, but we're going to go ahead and do this algebraically. So for L, we're going to do D of Q is equal to S of Q. So if we think of this as the supply function and demand function, what we're looking for is where, right? And so this is the price. Where does the price equal the quantity, basically? Where's the equilibrium, if you will? Right, so this is be S of Q, and this is would be D of Q. Okay, so then D of Q we know is 16 minus 1.25 Q. S of Q is 0.75 Q. If we solve for Q, we get that Q is equal to 8. And then we can say, okay, well, what's the price? S of 8 would be 0.75 times 8, which equals to 6. So equilibrium is 800 watches at $6 a pop. And that's how you do 27. I'm going to leave 28 as extra. Do not complete. Let me see. I don't want you to graph it, so don't complete K. Also, you can skip G, I think it is the one that's asking you to graph, K and G. Do not complete K and G in those. All right. The next one I have is number 33. So number 33 is the break-even analysis. So break-even analysis occurs when the revenue function is equal to the cost function. So in this case here, they're telling us that the cost function for this particular problem is 5x plus 20. And then they're telling us that the revenue function is equal to 15x. And then all of these are in dollars. So what is the break-even quantity for this, right? So if we go back, if we think about this for a second, we can use the information that we've been provided to find this out, right? And so here, revenue function is equal to cost function. So it's going to be 15x is equal to 5x plus 20. And so here is going to be that 10x is equal to 20 and x is equal to 2. So break even is 2 units. So if we produce 2 units, we get a break even with no loss, no function or anything. I mean, no loss and no profit. The next one is part B. Let me get to this thing. Whereas, what is the profit from 100 units? So this is A. So part B, the first thing we got to do is we got to find the profit function. So remember, P of X is equal to the revenue function, or R of X minus C of X. So profit is equal to revenue minus function, minus cost. So 15x. And then notice how I put this in parentheses. It's 15x minus 5x minus 20. And so in this case here, if we do 10x minus 20. So it looks like the profit function is going to be, in this particular problem, 10x minus 20. So now the next thing that is asking us to do is to find P of 100. So P of 100 is going to be basically 10x, or 10 times 100 minus 20. And so we're going to get 980. So the profit from 100 units is $980. So the next thing for C here is asking us when P of X, in other words, when the profit is equal to $500, what do we get, right? And so we're going to do 10x minus 20 is equal to 500. 10x is equal to 520. And we divide both sides, we get x is equal to 52. So for a profit of $500, you must sell 52 units. All right. That is 33. Let's go ahead and look at 34, which is the same thing. And that would be the end of 1.2. So it says the cost function is equal to 12x plus 39. The revenue function is 25x. Find the break even. That's when R of x is equal to C of x. So 25x is equal to 12x plus 39. And so this is just a simple, just combine like terms. And in this case here, x is going to be equal to 3. So break even is 3 units. All right. The next one for part B, it's saying find a profit from 250 units. So again, for this particular one, the profit from 250 units, and it's just good habit to memorize this. So this is going to be 25x minus 12x plus 39. And so in this case, we get 25x minus 12x minus 39, which is 13x minus 39. So the profit function is 13x minus 39. So what they're asking us to find here is P of 250. And so P of 250 will be 13 times 250 minus 39, which is going to give you 3211. So the profit from 250 units is $3,211. All right, well,